Hello all, today we are solving LeetCode problem number 1292, maximum side of length of a square with sum less than or equal to the threshold. So we are given a m cross n matrix basically, and also given a threshold value. So we have to return the maximum side length of a square such that the sum of the square is less than or equal to the threshold value. If we could not find any square with some value less than or equal to threshold, we have to return 0. So let us understand this problem by going through the first example. So here the given threshold value is 4, right? And you have to find a square which will the values within the square will sum up, and you will get the value which is less than or equal to 4. So you can see here the square of 1 cross 1 is 1, which is less than or equal to 4, right? And you can see one more square here which is 1 2 3 4, the sum is 4, which is 4 is less than or equal to 4. And if you see this 3 cross 3 square, the sum is 12, 21 and 29. So 29 is greater than, so this is not equal to, less than or equal to 4, right? So in this, because of this, we cannot consider this size. Instead, we can also see here the 2 cross 2 square, the sum is 4. So because of that, we have 1 cross 1 square and 2 cross 2 square, which can form the sum up to less than or equal to 4, and the maximum among these two size is 2. So because of that reason, we are returning the output as 2 here, right? So now let us understand this by solving a simple problem, and let us come up with how we are going to solve here. So from this first example, if you note down on observation, let me write down the observation here. You can observe that for a square of size 1 cross 1, it is true, and square 2 cross 2 also it is true, and square 3 cross 3, this is false, the condition is false, right? So because of that, we stop and we cannot proceed further because this is monotonically in the form of monotonic. So we can come to a conclusion that the pattern, by using pattern matching, so whenever the problem is monotonic in nature, we can solve by binary search, right? So, and here we have to calculate the sum, right? So for calculating the sum, that always, to calculate the sum, it will take order of n cubed complexity. So because of that particular thing, we can configure, we can find the sum by using prefix sum method, which is prefix matrix sum. So using that, we can reduce the time complexity so that we will have all the possible sum for a particular cells available there, so that we can use them and check, find the threshold value, right? So with these two methods only we are going to solve. So let us solve the second example, because this is a smaller one and we can solve this, and we can go ahead with the observation and then proceed with the coding part. So we have to have a prefix matrix, so which is, we have m cross n, right? So this should be, the prefix should be, p should be m plus 1 cross n plus 1. So because of that, 3 cross 3 will be 4 cross 4 for prefix. So let me draw down, and 1. So to find this particular element, right, so we start from I plus 1, filling the prefix, and j plus 1, because this will be I and j, and we will be starting to fill the prefix by I plus 1 and j plus 1 as the index, and this is the ith index in the matrix, right? uh, Oops, this it's not ith index, it's a 0 cross 0 cross 0 comma 0, and this is the first value, right? So in the matrix, so to find this, we have to sum up the left and the top and subtract this, the leftmost diagonal, and sum with the matrix value of that current index to get the value, right? So as a result we get 1 here, and when we jump here the left value is 1 and again 0 0, so this will be 2, and here the left value is 2, and I forgot, sorry, this, and the matrix value is 3, so this will be 5, right? And coming to this, we have 2 here, and top is 1, and there is 0 0, so there is nothing to subtract, so this becomes 3, and again here 1 plus 3 plus 2 minus 1 because of this, so this becomes 3 3 6 6 5, yeah, and 5 5 10, and this is minus 12 and 2, this becomes 10, and again this will be 3 and 1 4 and 7, then 17 minus 5 is 12 and plus 1 is 13. So this is the prefix matrix where we got. Using this prefix matrix we can calculate the sum of till sum of the squares in the matrix. So for example, for calculating this particular square, we can look in the prefix matrix, the sum is 5, right? So this is how we calculate. So based on this observation we can make it as prefix of I plus 1 and j plus 1 is equal to the current cell value in the matrix, which is mat of I and mat of j, plus this will be p of left and right, sorry, left and top, so p of I plus 1 and j, and plus p of I j plus 1 subtracted by the top left, right? So that will be p of I j. So this is the observation to the formula to calculate the prefix matrix at a particular index position, right? And now we have to we have to calculate, we have to run the binary search, right? So how we will be running the binary search in the range of length. So based on this example we can say that this is a 3 cross 3, so the minimum of m and n will be the value, uh, the maximum value to form a square, right? So in that occasion here it is 3, so we have the range from 0 to 3, so L will be 0 and R will be 3, right? So 0 1 2 3, L and R at this position. Now we are looking for binary search, right? So now we will be calculating the mid value, and the mid value will be 3 by 2. No, this will be R plus L plus 1 by 2. So in that case plus 1, this will be 2, mid will be 2. So now for side 2 you have to check, it's not check, we have to find all the possible threshold, right? So we define a function, separate function, example def check. We pass in the value, we let that be k, and now you have to go through the prefix matrix, iterate through prefix matrix. So at what position we have to start and what position we have to check, because we have the complete matrix, right? So it is not advisable to search through the complete matrix. Instead we have to look for a certain row and certain column. So in that case we have k value here, so we subtract that from, because we iterate m plus 1 and n plus 1, so we subtract k from there, and this will be the range we start, and we start from and iterate through the prefix matrix and find the total value, which will be prefix of uh, this will be I plus k and j plus k, right? So now we calculate the value which will be total, and we check with a threshold less than or equal to threshold. If we found one particular square having the value, then return true. Else run through the complete iteration. If we couldn't able to find any square satisfying this condition, return false, right? So now with all this observation, let us go ahead and code this up. So the time complexity, this will be big O of n cross m, and since we are doing by binary search, this will cost us log n operation as well. So because of that, tc will be big O of n cross m, and log of this will be minimum of m and n. Why? Because for the binary search, we are choosing the left the right most bound to be the minimum value among m and n, right? So because of that, it is that. So now n is equal to len of nums, right? Sorry, len of mat, and m is equal to len of mat of 0. This should be altered. This, yeah, so because row is m and column is n, so because of that particular reason. And now you should define the prefix matrix. So let that be p is equal to, and you have 0 multiplied by 0 times, this should be till length n plus 1 prefix, and for in range till m plus 1 times, right? So we have created the prefix array, and now you have to fill in the prefix array, basically. It's not array, prefix matrix. So for filling in, you have to iterate, right? So for this should be m, and the next one should be n. For j in range n, right? So now here you have to fill in the prefix value. So that should be p of I plus 1 and p of I because everything is initialized as 0, so you saw in the diagram, right? So because of that reason, we start filling from I plus 1 position. So j plus 1 is equal to matrix of I j, and then p of I and j plus 1 plus p of this should be I plus 1 and should be j, then this should be subtracted by p of ij, right? So now we are done with creating the prefix matrix. Now we have to define the function if it is if it can form the value less than or equal to threshold value, right? So uh, through which we can say that that particular size can be feasible, right? So def, this is can or capable or whatever. So we are passing in k as the value, and again we have to start iteration. So for I in range, and this will be m minus k plus 1, and for j range, this will be n minus k plus 1. So now we have to find the total. So total is equal to prefix of I plus k and j plus k, right? And this will be subtracted from prefix of I and j plus k and prefix of I plus k and j, and this should be added with prefix of ij, right? So now you have to check if the total is less than or equal to the threshold. So if threshold check, uh, so if total is less than or equal to return true, right? And if it is not, return false. So we are done with the other can function, which will check if the possible size or the k value uh, could form a value which is form a total which is less than or equal to threshold value, right? So now you have to do the binary search. So low and high is equal to 0 and minimum of min of n and m. So you are setting up these pointers, and now while l less than or equal to h, you start your binary loop, and for finding the mid value, this is equal to low plus h plus 1 divided by 2. So you get the mid value, and now you are applying, if substituting the mid value as the parameter to can function, so that it checks if it could form a total value which is less than or equal to threshold value, right? So if can of mid is true, then low is equal to mid, okay? Else h is equal to mid minus 1, decrementing the you are reducing the size or the range, right? And this is the success scenario. So because of that, you keep on updating l, and when the loop breaks, you stop at a place where you have the highest side or the largest side which could possibly form this uh, true return true value out of the scan function, which forms a value or total value which is less than or equal to the threshold value. So return l here. So now let us go ahead and run this. Yeah, let us submit this, and there you go. This is pretty efficient solution. Thank you.